Alright, so what I did was highlight these. You don't have to highlight these, but I just want you to be aware that these are the perfect squares and not the numbers next to them. So like 3 is not a perfect square. It is what the square root of 9 simplifies to. So, I mean, you can circle that or highlight it if you'd like. You will need a calculator. And I'll show you how to find all the things in the calculator. I feel like this is blurry. Is this just me? Maybe it's not. Maybe that's better, maybe it's the exact same, I don't know. So, first things first, if you do have a perfect square, like 36, all you have to do to simplify it is just turn it into the whole number. It's just 6. So, don't overcomplicate it and put it into y equals if it is a perfect square. Alright? If you have a really large number under the square root, I would suggest the first thing you do is just put it into just the normal calculator. So click the blue second x squared and then type in that number and see if you get a whole number. And if you do, then you're done and you don't have to do any more work. But if it's not a perfect square, then we have to go through this process. It's written right here. You're going to try to find the largest perfect square. So it's important that it is the largest. The reason is if it's not the largest, you have to do the whole process again and double the amount of work that you have to do. And we don't want that. So what we're going to do, which we have done this in the past, but it's the same process, nothing really new today. But y equals, so there it is. And then you're going to type 72 divided by, and then x is next to the alpha button. So again, it's just the number. It's not the square root of 72 divided by x. It's just 72 divided by x. Then you're going to go to the table. So you're going to click second graph. And then you're on the table. All right, so here is this table. I feel like it should be showing up better. Maybe if I do this, it'll show up a little better. Oh, that's better. Yeah. So the largest perfect square that goes into this is 36. You just look on this blue side. But also notice 9 is there as well, which is another perfect square, but it's not the largest one. So we're going to use 36. Next to 36 is 2, because 36 times 2 is 72. So it just, all we're doing is splitting them apart. We're not actually changing anything. We're just simplifying these. Like you would simplify a fraction. It's just a different process for simplifying radicals. We're simplifying square roots. The square root of 36 is 6, just like we just learned. And then you just bring that square root of 2 down, and you're done. And that's all that you do. And then how do you know you're done? Because no other perfect squares are factors of 2. All right. If this was a number that had a perfect square that was a factor of it, like let's say this was 8, you'd have to go through the whole process again. Okay. Next we have 50. All right. So for 50, a lot of you guys can look at it and know, well, 25 goes into this twice. If you don't know that off the top of your head, that's perfectly fine. That's why you have a calculator. You just type in 25 divided by x. Nope, that's not right. 50 divided by x. And then you realize, oh, 25 is a perfect square, and 25 times 2 are the two factors that multiply to equal 50. And so that simplifies that to 5 root 2. And then you're done. All right? That is fully simplified. All right, then we're going to look here at 400. And so what you might be tempted to do is just initially go and type it in to y equals 400 divided by x, but that would not be the quickest way to do this. Kind of like I said earlier, anytime you have a large number, if you aren't very confident with your perfect squares and don't have all of them memorized, then just start by typing the number into the generic calculator, square root of that number. If you get a whole number, you're done. If you don't get a whole number, then you can go through the process. But I find that sometimes we have a perfect square, but we try to simplify it, and then we just get stuck and we get in this loop. You can still simplify it because 4 and 100 go into this. The thing is, they're both perfect squares, though, so you can simplify both of them. And then it confuses people. All right, so what I'm going to do now is I'm going to pause, and I want you to solve this one real quick. So type it into y equals. This one is not a perfect square. And see if you can figure out what that perfect square would be. All right, 216, you're going to take the two perfect squares, which I have them here, 36 is your largest perfect square. None of the numbers above them are perfect squares, like on our list up here. Therefore, 36 times 6 are the two numbers you split them into. So see, make sure you wrote 36 first, because that is the perfect square. You want to write that number first. And then 36 simplifies to 6 outside the square root, so 6 root 6. Oh, goodness. Got a little crazy. That's it. All right. If you got it, great. If you didn't, just make sure you pay attention to this one as I go through this process again, and kind of figure out where your mistake was. For this one, just, if you don't know your perfect squares, try typing that in. If it comes out to a whole number, great, you're done. This one doesn't. It's not a whole number. So that's what tells us that we need to go to y equals and simplify this. And you may be looking, you're like, wait, this has a 2 in front. Why are we not dealing with the 2 right now? It's because we're going to wait till the very end, and then we'll incorporate that 2. So we're only focusing on things under the square root at first. I'm going to go to the table, and then I'm looking, I'm like, okay, no whole numbers until 49. Bam! That is a perfect square, so that's good. So we found it, and it's kind of easy to find on this one because none of these numbers are whole numbers. But you get to the first whole number, and it is a perfect square. So I'm going to bring this 2 down so I don't forget about it, but I'm not actually going to do anything with it yet. And then I'm going to bring my 49 down, and I'm going to bring my 7 down. Don't forget to leave these under the square root until you've actually taken the square root of 49. All we're doing is splitting them. The first step is to split. The second step is to simplify. All right? So we're going to split 49 and 7. Simplify. So I'm going to put the multiplication symbol because these are getting multiplied. And then I'm going to bring that square root of 7 down. Can't do anything with that. 7 is a prime number. No perfect squares go into that. And then your last step is just to take this 2 and multiply it by whatever number's on the outside. Because things that match can get multiplied. You cannot multiply this 2 by the 7 underneath. I see that a lot. People are wanting to multiply these together. They don't match. Can't do that. You can multiply these because they are outside the square root. Alright, so this is your final answer for this one. Alright, so just like I said just now, you can multiply things that match. What does that mean? The 2 and the 4 outside the square root, they match. So that can become 8. You can't multiply the 2 and the 6. Not allowed. The 27 and the 6, you can multiply those. I don't know what that is, though. 162. That's good. 162 is not a perfect square, so we have to put it in here. And then we go, and it doesn't take that long to get to a perfect square, though, because it's actually 2 times 81. 81 is a perfect square. So you guys may be noticing, the better you know your perfect squares, the easier this is. I have them listed on the page, but if you have them memorized, it's going to make your life easier. Alright. So 81 simplifies to 9 outside the square root, and then we take this number in front and we multiply it by the 9. So 72 root 2 is what we end up with here. But see the steps and how we go through this? And you can only multiply things that match. So we pull these apart, we simplify, we multiply the 8 and the 9. The 2 does not get touched. Alright, I'm going to pause one more time, and I want you to solve number 8. You're going to go through the same process. These numbers are smaller, so it's a little bit easier. Multiply, and then simplify. Alright, so we multiplied the 2 of these. 3 times 2 is 6. 8 times 6 is 48. And then, oh goodness. I was not prepared. Here we go. Looking at our perfect squares, 16 is the largest one. 4 is also a perfect square, but we're not going to use that one because 16 is bigger. We want the largest perfect square. So don't forget about the 6 in front, but then split this into 16 and 3. Square root of 16 is 4. You multiply that, you get 24 root 3. Okay, this is the gist of what we're doing today. I am going to show you number 9 because this is going to help us for something that we're learning next week. And you may think, why are you doing it now? We're not learning it till next week. Well, next week is going to come around pretty quick. And then I don't want it to be the first time you've ever seen this process because we're going to be learning all different weird stuff that day too. So I want you to at least see this. So it's weird. You got like a fraction here, and that fraction bar just means to divide, basically. So it's the same thing here. Like you can multiply things that match. You can also divide things that match. So, you know, you can simplify that fraction, the 8 and 8 over 12. It simplifies to 2/3 if you don't know what it is. Yeah, I mean, you could type it in here. Like, the square roots would still be on it. But it just follows the normal mathematical rules of this can simplify to a 2, this can simplify to a 3. Don't let the square roots freak you out. If they both have square roots on it, just simplify it. Can't do anything with the 6 because nothing else matches. There's no other whole numbers to do anything with. And then you're like, I'm done. You're not done. This is actually kind of a longer process because we have to get rid of the square root in the denominator. You remember that word denominator? Like the bottom of the fraction. Anybody know what the top of a fraction is called? Numerator. Look at us. Numerator, numinator. Whatever we think. No, it's numerator, but yeah, close. So in order to get rid of the square root on the denominator, you have to multiply it by itself. And I'll show you why that works. It's because the square root of 3 times the... What is happening? Square root of 3 times square root of 3 just becomes a whole number. Alright, y'all stick with me real quick. We're almost there. Give me some time. So, you gotta multiply it. This times this ends up just becoming 3. But you can't just completely change it and multiply it by a random number. You have to also put the square root of 3 on top. And the reason for that is that the square root of 3 divided by the square root of 3 is just 1. So you're not actually changing anything. You're just multiplying it by 1. But it allows all the math rules to be, you just can't have a square root on the denominator. And this changes it around so it makes it okay. So 6 root 6, we're going to multiply across. Can't do anything with this, but you can multiply 2 times 3 to get that. And then 3 is right here. Root 3 times root 3 is 3. And then you're like, oh, I'm done. No, you're not. You can simplify 6 divided by 3 to get 2. And it's not 2 root 3. Don't do that. I don't know where the 3 came from. It's 2 root 6. Just bring that square root down.